Two traders, same stock, same hedges. Both bought $1 million of XYZ at 100, both hedged with options. The stock oscillates for a week, a few dollars up, a few dollars down, ends back at 100, exactly where it started. Alice's profit and loss, plus $5,000, Bob's, minus $5,000. Same trade, same path, different outcome. There's a force inside options that doesn't show up in any price ticker. It's why some traders sleep well at night and others lose everything in a single day. Before the math, the basics. A call option is a right, the right to buy a stock at a fixed price. The strike at some point in the future. If the stock rises above the strike, the option gains value. If it stays below, it expires worthless. Here's the option's value, today, as a function of the stock price. Imagine it as a landscape. Walk left, the option is in the valley, worth nearly nothing. Walk right, you climb. At the strike, right here, the slope is changing fastest. This isn't a chart, it's the terrain your option lives on. As the stock moves, you walk the surface. Your altitude is the option's value. Delta is the slope of the terrain at your current position. Take a step in any direction, delta tells you how far you'll rise, or fall, as long as you take a small step. Watch. A ghost walker, what delta predicts, extends a rigid platform from where we stand, tangent to the curve, straight. Step $1. The terrain walker and the ghost walker land in nearly the same place. Step 5. The ghost is below the terrain by 80 cents. Step 10. The gap is nearly $3. Step the other way, down $10. The ghost walks straight off the bottom of the canvas into negative territory. Options don't have negative values. The terrain knows, the tangent doesn't. The further you walk, the more delta lies. Gamma, the rate at which delta changes. To see what that means, the two traders. Alice owns one call, Bob sold one call, same strike, same expiration. Right now, Alice's effective stock equivalent position, what traders call delta, is plus 0.51 shares. Bob's is minus 0.51. Same magnitude, opposite signs. Watch what happens when the stock moves. Stock ticks up $1. Alice's effective shares grew from 0.51 to 0.58. She's effectively longer the stock than she was a moment ago. She didn't lift a finger. Bob's went the other way, minus 0.51 to minus 0.58. He's effectively more short. The stock moved against him, and the math just made him more exposed to the next move continuing in that direction. The number that governs how fast both badges move is gamma. Stock keeps rising. 100, 101, 102, 105. Alice's effective shares grow to 0.81, from half a share to 4/5. Bob's is the mirror, minus 0.81. And here's what that means for profit and loss. The gamma effect isn't linear in the stock move, it's quadratic, the square of the move. Side length is the stock move, area is the move squared. Multiply by half of gamma, that's the gamma contribution. Double the stock move, quadruple the gamma effect, squared. When the stock comes back down, Alice's effective shares shrink. She's auto-protected. Bob stays short and gets shorter. The math is doing the work. Long gamma rebalances in your favour, short gamma rebalances against. That's why Alice profits and Bob loses on the same path. Now scale this up. Bob isn't one trader. Bob is every dealer who sold calls to retail buyers. When the stock rises, every dealer is effectively shorter. They have to buy stock to hedge, to stay neutral. Watch the loop. Stock rises, dealers' net position turns more negative. They issue hedge buy orders. The buying pushes the stock higher. Higher stock makes them shorter still. They buy more. Each iteration the arrows get thicker, the numbers bigger, the stock moves faster. and gamma explodes near expiration. On a 30-day option, at the money gamma might be 0.07. On a 1-day option, it's more than 5 times that. January 2021. GameStop. Stock from $20 to $483. Most explanations blame retail traders. The math says they squeezed gamma. The dealers who'd sold calls were short gamma. As the stock rose, they were forced to buy. The buying pushed the stock higher. Their hedging needs grew. They bought more. The same loop, played at scale. On a 30-day option chain. One more thing. This shape, the curvature, the gap, the second derivative, isn't unique to options. A bond's price-yield curve, an option's price-stock curve, a pendulum's restoring force. 3 different terrains, 1 walker on each. Same tangent platform extending, same gap opening. Convexity in bonds, gamma in options, acceleration in physics. The same mathematical object, wearing 3 different uniforms. Once you can see the bend, you can see it everywhere. If this clicked, like and subscribe.